Welcome to my channel AI Basics with AK. Here we are with another new episode on multi-threading and multiprocessing. So why waste time? Let's directly jump into our episode. So in today's episode, we will be discussing both multi-threading and multiprocessing. It's very simple episode because I'll be discussing only conceptual in the slides. And when coming to demo, I'll just run through the simple code. So this is a very good conceptual understanding, might not be too much applicable at this point of time. But when we go into further computations, large computations, maybe that's where it is required. So let's understand the concept of multi-threading and multiprocessing with a simple example of the person shown on the left-hand side. So what is she's trying to do? She's seeing the mobile phone and she's trying to write. And even she is drinking coffee or tea, whatever it is. And then at the back end, it's both, she's processing both her mind by reading on the phone and writing it here, and she is processing her stomach. So think that this is like a two processors. This is processor 1 and this is processor 2. So these both things can happen simultaneously. But however, this activity 1 and activity 2 cannot happen in parallel because she has to see and then write. Even if they are fast writers, by seeing and copying it, there will be a 1 second delay or a 2 seconds delay. Say for example, if I'm doing multitasking, by doing juggling with various activities, I might not be doing everything in parallel, but I'm trying to plan every activity in a very simultaneous way where switching is very easier for me, right? I can switch from one task to another task, other task to another task. So that's very easier. Say for example, if I want to cut onions and watch TV, I can do it simultaneously. It's a multitasking because I can say if it's very big onion or if it's the first time I'm doing, I slice it slowly and then watch TV. I slice it and then write. So multi-threading is like an activity where we switch the tasks in a very seamless way. However, multiprocessing is that there are two activities that can happen in two different processor systems. One of the best example I would say for multiprocessing in our daily life, in particular my daily life, would be while doing gym, I listen to music. These are two parallel systems, right? However, multi-threading in my daily life would be as simple as like maybe I'm reading something and I'm writing a blog. Both can happen in a very fast way if I'm trying to comprehend what I'm trying to write the blog. So let's understand the formal definitions of multi-threading and multiprocessing. Multi-threading involves executing multiple threads within a single process. This is what we have learned. Similarly, threads share the same memory space, making communication efficient between them. Like here, she's trying to use the same mental processor, that is their brain, and trying to switch between the tasks, but sharing the same memory space here, right? So that's how it is. While coming to multiprocessing, it involves multiple processors in its own memory space. So the processor do not share the memory, it has its own processing system, but makes the computation more complex. But it also enhances the stability of it. So that's the more formal definitions. So let's reinsert the same learning using this pictographical way of presentation. So when to use the multi-threading here, say on the right hand side, if you can see here, multi-threading is beneficial when your program spends time waiting for external events such as reading files or network operations or an user input. Because since we are using only same processors, when there is a time lapse between these events, we can switch from one task to another task, because it's waste of time to just stay on the same task when we can use that specific memory for another task. So that's where we can use those multi-threading concepts. In the same way, when we go back to the previous image, say for example, if I'm writing and reading, however, if I want to write a better blog, I have to read better, and then whatever I have read, maybe I would have comprehended in a different way. And since I do not want to lose that context, I'll come to my blog and write that piece of writing. So that's how it happens, right? Like I don't in generally complete all my learnings in one go and then come to blogging at times. Maybe few people do it, but this is what my behavior it is. Like, I switch between these tasks. So multi-threading is specifically beneficial when when your program spends time waiting for these external events. So these tasks are ideally your input and output bound. So that's where we can benefit much more from using multiple threads running concurrently. Make sense? Now, multiprocessing is ideally used as CPU bound tasks, because here, say for example, why we need multiple processors, it came much more useful. Say for example, we want to do complex calculations, maybe a complex data analysis, maybe we want to use image processing. Here we want to use as much processing capacity that we have in our computer. So that's why we want to use this entire processing systems in parallel, such that we can achieve our computation at a minimum time. So both of them are multitasking because we want to achieve them fast. Multiprocessing is much more better because we are trying to use multiple processing systems at the same time, because we are not wasting the processor space that is available at our end. Got it? Now just let's summarize our learning using these comparison tables. Execution model. Here multiple threads runs within a single processor. That's what we have seen. While multiprocessing has each in its own memory space. Since it has only single process, it has a shared memory. However, multiprocessing has separate memory spaces. Overhead is lower because it switches, but here overhead is higher because it has remembered more complex calculations, because it has to understand the entire processor communication, which is actually here what we can see it here in communication. Because it's easier, it has a shared memory, but here we have to process that inter-process communication also, because it's between multiple processors. So it's both useful for ideally in input and output tasks, but here it is more CPU bound tasks. Stability, less stable because it's using the same memory. It is more stable because it has an isolated process. Efficient for tasks requiring this data, the performance, but efficient for parallel processing. Ideally, we want to use all parallel process at a very fast rate, because the computation is more huge, then that's where it is required. I'll come to these discussions actually at a much more later seasons, especially when we are doing NLP tasks and image recognition tasks, where we will see them in much more clear. Maybe also we might be seeing while doing machine learning, especially using scikit-learn libraries, where we can also use parallel processing, especially which is called pandas parallel, while performing machine learning tasks on a larger scale. Multi-threading is a very small, but ideally we can use it while for let me actually go to the next slide, and then maybe I can ask you. So when to choose which? Scraping 100 sites in one go, computing square root of so many numbers in one go. Pause it for a minute and then try to give an answer. Here is the answer. Scraping hundred websites in one go. Most often we use Beautiful Soup, which we will discuss in the next season or the season third, which I'll come back to you. While doing Beautiful Soup, there is we wait for also the website to reload it and reload that web page and then process it. So since it's an input and output bound task, ideally we can use this for multi-threading. However, when we are trying to compute square root of so many numbers, we can do it something in parallel, right? That's where we can use our entire CPU processes, whatever it is available, such that we can achieve it in a quicker time. That's it for theory. Let's continue further learning in our demo, where we will substantiate our theoretical learning with some practical codes that we can explore using Python. See you there. So in this demo, we will first start learning a basic syntaxes of threading and multitasking by quick demonstration. First, let's define two tasks. So say for example, we have a task 1. Say for example, it might take maybe 4 seconds. Okay. And after completion of that task, let's print that statement saying task 1 has completed. Similarly, task 2, say for example, it might take say 6 seconds. Since I have used time.sleep, I have to use import time, and let's check this out. What will happen if I am not using multitasking? What ideally happens? Task 1 runs for 4 seconds and then task 2 runs for 4 seconds. Okay, that's how it happens, right? Now let's try to run it. So 1, 2, 3, 4, and then 1, 2, 3, 4, 5, and 6. So yeah. Now you can see that it took totally 10 seconds. Maybe say for example, if you want to do them in parallel, that's where we can use our threading concept. How do we do that? Let's first import the library called import threading. And how do we create threads? Let's create a thread 1. How do we create a thread 1? By using thread, and then we'll say it's a thread. What is our target? Target is nothing but what we want to do that with that thread. We want to run the task 1, right? That's our primary purpose. Similarly, what we want to do with thread 2, our primary purpose of running this thread 2 is to run our target task 2. And how do we start these threads? Thread 1, simple. It's thread 1 dot start. It starts because we have to run both the threads in parallel. Concurrently, not parallel, sorry, concurrently. And then we have to tell that it's shared memory, right? Because we have to ensure that it waits for time, because we have added here some time to simulate an input output task. So that's we have to tell that, okay, you have to run concurrently, right? So that's where we join this thread such that when one is waiting, other will start, kind of a thing. So that's where, and then both threads wait ideally until both of them gets completed. That's main purpose for this join statement. Now when we run it, ideally both of them will have to complete in 6 seconds, because one of them is waiting for 4 seconds and other is waiting for 6 seconds because there is a wait time. I have simulated is here an input output task by incorporating a sleep statement here. So after 4 seconds, task 1 gets completed. Similarly, after just 2 seconds, the task 2 gets completed. When I ran it, I ran it before saving it. So once after saving it, it exactly ran after 2 seconds. Okay, I can just demonstrate it again here. 4 and then after quickly 2 seconds. That's how it is, right? So that's how the threading helps us. So similarly, the processing also does in the same way. What we will do is that we will use the same input output task to learn the syntax of processing here. So instead of threading here, what we can do here is that we can change it to multi-processing. And here we can create something like process 1 in the same way, multi-processing dot process target equal to task 1 process 2 multi-process. Syntax is almost the same. I am trying to demonstrate the syntax for the same input outbound task, which is ideally we should not use multiprocessing for the input outbound task because we cannot differentiate it. So process, I'm trying to start it because this is one process, and here I'm trying to start the another process. And how to, here too I have to join because I have to ensure that all processors wait for other processors to complete. So the running, let me just save this. Now after running this, oh, it requires the main here. I'm very sorry. Ideally, for running processors, it requires name. We have to run inside a main function. My mistake. So I'm just ensuring that the indents are in the right place. And after running this, let's print a statement that both processors are done. So almost syntax is almost the same, except in processing we require it to be run from the main function. Got it? So my mistake again. It has to be double equal to always. Now when you run it, it runs in the same way. But here we are unable to differentiate the difference. Why we need to use multiprocessing and multitasking? Because we have used the same example. I'm trying to demonstrate the syntax. The syntax is almost the same. We create threads, thread.start and thread.join. Similarly, we create processes, we create, and then we start the process and join the process. Now let's create a little bit. We start a time, end a time using one multi-threading. Similarly, we start something process and then end a processes, and then we see, okay, which is completing in a faster way and in a slower way. Okay, so for time bound, what I'll do is that I have written one code which I'll just try to copy paste it here. So here, what I'm trying to do is that I'm trying to create one heavy bound, heavy CPU heavy tasks where I'm trying to compute, okay, a range of computations by adding them, and then I'm saying that the thread is done, kind of thing. Here I'm trying to say the thread started and thread ended because I'm trying to create here 4 threads. Simple. And then I'm joining the threads and I'm trying to calculate the start time and the end time, kind of a thing here, such that we'll understand how much time the total time it took for this code to run. Okay, so 4 threads has started, 4 threads are completed. The total time it took for multi-threading using this CPU heavy task is 3.2 seconds. Now let's run the same code with using multiprocessing. The process remains the same. Here, instead of threading, we have to change here processing. I'm just creating the func that code again. 4 processes started, and then let's see the 4 processes ended. Now you can see that the time is 2.17 seconds. So here we can see that in a CPU bound task or a heavy task, the multiprocessing achieves the task at a faster rate, whereas multi-threading took a little bit longer time. So you could able to differentiate, like, okay, with an input output task, when the task has to wait for one task to complete where we have added sleep, kind of a thing, that's there we don't need to use processes. There we can use threads. However, when we are doing a larger computations, here it's a very simple computation, the difference is only 1 second, but think about we are doing a larger computation, that the time will be very different. So that's where we can come to multiprocessing, where we can use our multiple processors that are there. Here in my system I have 4 processors, so that's why I'm able to use uh, take only 4 processors at this point of time. Okay, so that's it for today's episode. Okay, we will come back in our next episode with another new episode and continue our learning in Python. If you like this episode, please give a thumbs like and share your comments by writing what you want to learn further in this Python journey. See you soon in next episode. Bye bye.